welcome back. I hope you're refreshed. We're going to do one more question, okay? And I promise it's not as long as the last one. Okay, so just to remind you what we're looking at today. We're looking at components, okay? So we've been looking at forces, and we're particularly looking at components. So let's look at one that's a little simpler than finding the net force. Okay, so what we have is we have a lady waiting for a taxi. She's pulling a 20-kilogram suitcase with a strap. So she's pulling it at an angle at a constant velocity. So now the constant velocity is quite important because it means when we look at it, constant velocity, there's the constant, that the forward forces and the backward forces are equal, okay? Makes an angle of 30 degrees to the horizontal. She pulls on the strap with a force of 35 newtons. Frictional forces between the case and the floor cannot be ignored. She can only pull it at constant velocity if there's friction, okay? Because if there's no friction, it'll accelerate. So, the 35 newtons is at an angle, and I actually have a diagram for us, okay? So we're concerned with what's happening there. It's at an angle. Remember, the suitcase is moving horizontally, so it's the horizontal forces that are important for us. First question, draw a free body diagram. Free body diagram means a dot, to indicate all the forces exerted on the case in both the vertical and horizontal directions. Now, this is a different type of question for you, because I don't want the 35, because that's at an angle. I want the other forces. So let's start with the easy ones. First of all, we have the dot. It's going to be FG, vertically down. Because there's gravity, there's going to be the normal force. That's easy. There's friction. Friction is going to oppose her motion. Now we've got to think about the force that she was pulling it at. Remember, it was at an angle. That means we have a horizontal component that's going to the right, and a vertical component that's going upwards. That's what they want on this one. They don't want the one at an angle. So here we have the horizontal component, and there we have the vertical component. Please be careful here. I know the normal force and the vertical force are both horizontal. You get very tempted to draw one line and put two arrows on, saying one's for the vertical and one's for the normal. Please don't do that. You must draw them as two separate forces. I must see them separately, okay? I know they're going in the same direction, and I know they'll add to each other, but they're not the same force, so we need two arrows for them, okay? And what we need to do is, I'm just going to make my dot a little bit bigger, because the forces must touch the dot. Please be careful with that as well. They must touch the dot because they're coming from that center point, okay? So now we've done the free body diagram. Now they say, calculate the component, so either the vertical or the horizontal, that will tend to move the case over the floor. It's going horizontally, so it's the horizontal component. Remember, we've got 35 newtons. This was 30 degrees. We want the horizontal component. Horizontal, it's adjacent, so we're going to use cos. So the horizontal component is F cos theta. So it's 35 times cos 30. I definitely cannot do this in my head. So let's clear my calculator. So 35 times cos 30 is 30,31. And she's going to the right. So we're going to put to the right. Done. See, much easier question. And we're done. Yes, bet you thought we wouldn't get a question that easy, but we are done. Okay, so just remember, when we do the summary, when the forces are at an angle, we have two components, vertical and horizontal. When we have an object that's on a slope, the weight has two components, parallel and perpendicular. And we are done for this lesson. Well done, and I'll see you next time.